Fossil fuels. So, fossil fuels are energy sources that form over geologic time from the compression and incomplete decomposition of plants and other organic matter. These include coal, oil, and natural gas, and these are non renewable. Once you get these out of the ground and you burn them, they are gone. These take millions of years to form. These consist primarily of hydrocarbons, and a hydrocarbon is a molecule with only carbon and hydrogen in it. So there's only carbon and hydrogen in these molecules. These are easy to transport where they're needed, especially coal and oil, because coal is a solid, oil is a liquid. They're very easy to transport. The main energy source in industrialized countries. These all originate from organic material trapped in sedimentary rock, and that organic material originally got its energy from the sun. A lot of these come from plant materials and algae. So, coal. Coal is the most abundant fossil fuel, and it forms from peat over millions of years. So, you have peat, you compress that peat, and that compression drives off the oxygen and hydrogen that are in that peat. Because the peat starts off with carbohydrates. So you have carbon, hydrogen, and oxygen. And basically you start driving off some of this water part of this, and you're left with mostly carbon. So this increases our carbon concentration here. There are three grades of coal. You have lignite, which is about 40% carbon. You have bituminous coal, which is what we have in West Virginia, and this is the most abundant type of coal, and it's up to 85% carbon. And then you have anthracite, which is 90 to 95% carbon. So, coal formation. So, incomplete decay of plants forms peat. So, peat comes from plants that die and then fall into bogs and then partially decompose and they form peat. The peat is then buried and compressed to form lignite. After further compression, you get bituminous coal formed. And then more heat and pressure are applied to form anthracite. And then lignite is a soft, brown, low-grade coal with low sulfur content, less than 1%. Because the carbon concentration in lignite is generally around 40%, it is inefficient as a fuel. More lignite must be burned than other types of coal to provide the same amount of energy. And lignite is this sort of brownish looking coal. Then bituminous coal can have carbon concentrations as high as 85%. When bituminous coal burns, it releases carbon dioxide and gases containing sulfur and nitrogen into the air, causing air pollution. And then anthracite can have carbon concentrations as high as 90 to 95%. It stores more energy and burns more cleanly than the other types of coal. However, it's not that common. Less than 1% of coal reserves in the United States are anthracite. Petroleum and natural gas. So most petroleum deposits form from the accumulation of microorganisms on the seafloor and ancient lake beds. Things like algae, cyanobacteria, etc. Incomplete decomposition due to stagnant water. Again, we have this incomplete decomposition of this organic material. This is buried under layers of sediment, increasing temperature and pressure, and then that eventually will form crude oil. Crude oil is collected from the surface or pumped out of the ground. This is refined into gasoline, diesel fuel, kerosene, etc. Natural gas forms along with petroleum and tends to rise to the top of the rock that the petroleum is in. But then this is trapped by impermeable rock. So impermeable basically meaning rock that the natural gas cannot flow through. And natural gas is basically methane, which is CH4. Crude oil is a mixture of a bunch of different hydrocarbons. We also have methane hydrates, which is methane, which again is CH4, like right here is our methane, but this is trapped in some solid material. Usually this is trapped inside a crystal structure made of water molecules, similar to ice. So these form in deep water and sediments where temperature is low and pressure is high. And these do actually look like ice that you can set on fire. Migration. So you have permeable rock, which is rock with pores and spaces that liquids can move through. Crude oil and natural gas migrate sideways and upwards away from the source rock, mainly because oil floats on groundwater. So you have groundwater in all of these, and then the oil and the natural gas kind of float on top of that. They accumulate then in reservoir rocks. So reservoir rocks are these permeable rocks where the natural gas and crude oil collect. They migrate until they reach a layer of impermeable rocks such as shale or slate. These are rocks that don't have a lot of pores in them, so the natural gas and crude oil cannot migrate through those. And then oil shale. This is fine-grained rock that contains a solid waxy material called kerogen. This can be mined, crushed, and heated until the kerogen vaporizes. And then kerogen vapor condenses into a heavy, slow-flowing, dark brown oil that we call shale oil. And then you could process this just like you would crude oil to produce gasoline, diesel fuel, kerosene, etc. And then the abundance and expense of oil shale. So the largest deposits of oil shale are in the Green River Formation in Utah, Wyoming, and Colorado. These are lake sediments that were deposited around 50 million years ago. It's estimated that there are about 800 billion barrels of recoverable oil, which is 3 times greater than the oil reserves in Saudi Arabia, which is where we get a lot of our oil from. Historically, oil from oil shale has been too expensive compared to pumped oil. It was cheaper to just pump the crude oil out of the ground. But current crude oil prices have made oil shale-based oil commercially viable. So the price of pumped oil has gone up to the point that it's cost-effective now to process the oil shale. Some issues with fossil fuels. So burning fossil fuels adds carbon dioxide to the atmosphere. Natural processes that remove CO2 do not occur on human timescales. So natural processes being things like photosynthesis and then plants dying and getting buried back in the ground. But CO2 builds up in the atmosphere because the natural processes can't remove CO2 as fast as we're putting it into the atmosphere. Fossil fuels also release other air pollutants such as sulfur dioxide and nitrogen dioxide, which then lead to acid rain. Because sulfur dioxide forms sulfuric acid and nitrogen dioxide forms nitric acid when it reacts with water in the atmosphere. Scientists, private companies, and government agencies are all studying renewable resources to try to replace some of our fossil fuel use.